Good afternoon, Year 10. So we are looking at more Pythagoras theorem today. So first of all, we're going to start with something called Pythagorean triples. What? They are three numbers that satisfy Pythagoras' theorem. So three numbers that you may have noticed satisfy are maybe 3, 4, and 5. Why do they satisfy? Because when we've looked at a triangle and the hypotenuse is 5, and we have the other two sides are 4 and 3, and it works. Well, how do we know it works as a Pythagorean triple? So we can test. So let's test to see if it works. If it works as a triangle, that squared will equal these two sides squared. So 5 squared equals 4 squared plus 3 squared. So here's my test. 25 from 5 squared is equal to 16 from 4 squared, and 3 times 3 is 9. So 25 equals 25. So it works as a Pythagorean triple. So these three numbers together. Now it's not that common that it works. There's not that many of them. You can see in your book on page 200 some of the Pythagorean triples. So you can always test numbers. So let's test 1, 2, and 3. Do they form a perfect right angle triangle? Kind of might. Well, you think they might. So if the longest side would be 3, so let's say that one's 2 and that side 1, does that work out as a right angle triangle? It will be a right angle triangle if 3 squared, the longest side, equals 2 squared plus 1 squared. Okay, maybe. 3 squared, 9 equals 4 plus 1 squared, 1. This is not going to work out. 9 does not equal 5, so that does not equal. I'll put a line through like that. So that 1, 2, and 3 don't work for a Pythagorean triple, so therefore they're not. So there's only a few numbers that combine to form Pythagorean triple. 5, 12, and 13 do. You can test that yourself. So 13 squared, does that equal 5 squared plus 12 squared? Yes, it does. Okay, so you can check out. So you may be asked, are these three numbers a Pythagorean triple? And you can test it. Just square each number, add the two smaller ones together. Does it equal the larger one? If yes, it is a Pythagorean triple. If no, it is not. All right. Moving on to problem solving using Pythagoras. So we're going to do one of the problems from the book. So hopefully you have the book with you. If not, pause and get it now. I'm going to do question 19 from the book on page 205. So go to that. So Pythagoras comes up in everyday life because, of course, there's right angle triangles everywhere in life, and you can even make them. For instance, if you have a rectangle, if you draw a diagonal from corner to corner, you've created two right angle triangles, and therefore you can find this diagonal on the other side. And it works for many shapes like that. Okay, so you can see some examples of that on page 202, which looks at isosceles triangles, equilateral triangles, squares, and rhombus, which is a square pushed out of shape slightly. Okay, so let's look at that question 19. A boat A is 10 kilometers east of a boat B. Okay, so there's two boats. Got to draw a diagram for these. If there's not a diagram drawn, you got to draw one. So here's A and B. East is that way. So A is east from B. So here's A, and it's 10 kilometers east of B. Okay, so east, remember, north, south, east, west. So that is a distance of 10 kilometers. Okay, cool. Boat A travels 6 kilometers north. So this A guy goes 6 kilometers up, okay, to this new point. That's 6 kilometers. So north and east would be at right angles, wouldn't they? So you can see how there might be a right angle triangle coming up here. Boat B travels 2 kilometers west. So boat B actually goes this way for 2 kilometers. So I'll make it a little bit smaller. It's 2 kilometers more. Okay. How far are the boats apart now? So we've got these 2 new positions. This is where boat B is now, and this is where boat A is now. So we're looking to find that diagonal distance from here to here. So what we have formed is a right angle triangle. We always know north will be at right angles to west and east, and south will be the same. So that is a right angle. So what distances do we have? We have that this distance is 12 kilometers in total when I add 2 and 10 together. And this kilometer is just 6 kilometers still. So how do I find out this distance, which I'll call x? Pythagoras' theorem. It's quite useful. X squared, the unknown side squared, is the hypotenuse. It is the longest side because it is opposite the right angle. X squared is equal to 12 squared plus 6 squared. X squared is equal to, get out your calculator, so that's 144 plus 36. X squared equals, add those 2 together, you get 180. Now you need to definitely get your calculator out. So the square root of 180 in a decimal form is 13.4. Okay. I look at my right angle triangle just to make sure my answer makes sense. 13.4. Yeah, it does make sense. It's going to be longer. 12 is quite a long side here, and it's going to be just a little bit longer than 12, so 13.4 does make sense. Okay, last thing we're going to do today is going to look at when right angle triangles occur in circles, and they do. So if you want some notes on this, go to page 206 and 207 of the textbook. So, an angle in a semicircle is one place that right angles come up a lot. Once we've drawn a diameter, I have 3 circles here with a diameter, and I put any point on the outside, so I'm going to use here, this one, and then join the corners to form a triangle, so either end of the diameter. The angle you have made up here is always a right angle. Okay, don't believe me? Well, let's do another one. So this circle, pick any point, let's do here, join, and there we go, another right angle. Of course, I'm doing this freehand, but if you did it absolutely perfectly, it would always be a right angle. We can take that as given. So I'll do one more, maybe just do something crazy over here, and then down, and you can see once again, another right angle. So the angle in a semicircle, when the diameter is one side of the triangle, it's going to be a right angle triangle. So you can see that they'll follow up this with some Pythagoras questions, where they give you the diameter, which will always be the hypotenuse of the right angle triangle, and maybe try and find one of the sides. Another theorem is when we look at tangents and radiuses. First of all, you need to know what a tangent is. So if I draw a circle, here's my center. A tangent is, so hopefully you did this last year, but if you don't, I'll go through it again. A tangent is a line that just tips off the circle. Only intersects at one point, just tips off. So most lines will either go straight through the circle and go through 2 points, or miss the circle altogether. This tangent is very special because it just clips the circle, just one intersection. And if you draw a line from the tangent to the center, well, that's a radius, isn't it? It will create right angles here and here. It will meet at right angles, perpendicular. And you can see that you can start forming some right angle triangles out of that, and then once again use Pythagoras' theorem. So if you want to do some circle problems, you can get on to exercise 10C, which is 208. So I'm going to be setting some Pythagorean triple questions, some problem solving questions, and some of these circle problem solving questions today, and then we'll go through more on Google Hangouts tomorrow. If you have any problems or questions, I can answer them then. So have the work done for tomorrow. Okay, good luck.